Hello, this is Joshua Sheehan, and today I'll be talking about student video number 6. So we start out with a cylinder is shrinking in such a way that the radius is decreasing by 5 centimeters per second, and the height of the cylinder is decreasing by 2 centimeters per second. Find the rate the volume of the cylinder is decreasing by when the radius is 12 centimeters, and the height is 10 centimeters. Round to the nearest whole number. So the first thing that I'm going to do is draw this. So it's going to be a cylinder. And we see here that it says that the radius is shrinking by 12 centimeters. So the original radius, we'll say, is this. And it is becoming smaller. At a rate of 2 centimeters per second. Sorry, I think I messed that up earlier. And then the height is shrinking. It's going down by 5 centimeters. Wait, it's the wrong one. This is 5, and this is 2 centimeters per second. All right, so we now have our drawing. We can also write out some things that we know. So rate of change of height, that's going to be negative. Both these values are actually going to be negative. So that's going to be negative 2 centimeters per second. And all of these values will be in centimeters and seconds for this. And the rate of change in radius is negative 5 centimeters per second. All right, and so we're finding the volume of the cylinder is decreasing when it's at 12 centimeters. So R is equal to 12 centimeters. And the height, H is equal to 10 centimeters. So we'll use the volume of a cylinder, which is V is equal to pi R squared H, adding height to the circle formula. And then we'll find the derivative of that. So the pi is going to stay on the outside, and then this will be a product rule. So the f of x is equal to R squared, the f prime is equal to 2r, and then dr over dx, and then g of x, oh wait, no, it's actually dt because it's a time. G of x is equal to h, and then g prime of x is equal to dh over dt. And that will make it dv over dt is equal to 2 pi, or 2r, actually I'll put the pi in the front though, 2r dr over dt multiplied by h, and then added to dh over dt multiplied by r squared. So fixing that all up, this is the not fixed version of it. Fixing that all up gives us dv over dt is equal to pi 2 hr dr over dt plus r squared dh over dt. So there's that. So now we have the derivative, and now it's just a matter of plugging things in. So we know that the dv over dt equal to pi 2. We know that the height that we're looking for is 10, so we can plug that in. We know that the radius is 12, so we can plug that in. We know that the rate of change for radius is negative 5 centimeters per second. Oh, and I should probably put these values in too. So this is going to be centimeters and this is centimeters. And then that is going to be added by 12 squared multiplied by dh, so that's going to be negative 2 centimeters per second. All right, so this is our plugged in values, centimeters. So dealing with a lot of centimeters per second and a lot of centimeters in general. So we are definitely going to get a centimeter cube, which makes sense because this is a volume problem. So I'm going to plug this into my calculator, and it's saying round to the nearest whole number, so I'm going to get rid of the pi in this case. So do this. All right, and with that, a very large number. This could be correct. Okay, this is the value that I plugged in, and this is what I got. So I may have messed up some plugging in there. It's still theoretically a possible answer for this. So rounding this to the nearest whole number, we get 4,675, and that's going to be centimeters cubed per second. And that will be our answer because it's the rate of change of volume, and that's what we wanted. So that is the answer.